1.7 Inequalities. In this section, we are going to learn use the properties of inequalities, solve the linear inequalities, and solve the compound inequalities. The trichotomy property. For any real number AB, one of the following statements is true: A less than B, A equal B, or A is bigger than B. The transitive property: if A, B, and C they are real numbers, then if A is less than B, B is less than C, then A is less than C. A is less than C. If A is greater than B and B is greater than C, then A is greater than C. Addition and the subtraction property of inequality. If A is less than B, then when A add C must less than B add C. So when I add a number into the both ends of the inequality, the direction, the sign of the inequality remain the same. Same way when you subtract a number. And similar property exists for greater, less equal, and greater equal. So when you add a same number into the both ends of an inequality, the direction of the inequality sign remain the same. There's nothing changed. Multiplication and the division property of inequality. If A is less than B, C is bigger than 0, then when you multiply C into both sides, the inequality sign remains the same. If A is less than B, C is greater than 0, when you divide by C into the both ends, the sign remains the same. If A is less than B and C is less than 0, which means C is a negative number, when you multiply C into the both ends of the inequality, the sign, the direction of the inequality sign, it swaps. It changes the direction. A is less than B, C is a negative number. When you divide by a negative number into the inequality question, you have to swap the sign as well. So this situation satisfies with the other three inequality sign as well. So now we learn how to solve the linear inequality. Linear inequality, they are the inequalities such as ax plus c is less than 0 or greater or equal than 0, where your a cannot equal 0. Numbers that make the inequality true when substituted for the variable are solution of the inequality. Inequality with the same solution set we call as equivalent inequalities. Okay, a lot of wording here is kind of confused, but the thing you need to know here is when we have the equation, for example, 4x equals 4. We solve for x by divide by 4, right? So we know that x equals 1. When you have the solution is x equals 1, if I interpreted this solution, I mean on the number line, this solution only at one point when x equals 1. This is a 1 point on the number line, only one solution. But now we are dealing with the inequality, right? So for example, I have 4x is less than 4. You process the inequality equation as the same way when you have the linear equation or the regular equation. You divide by 4. So you'll have x less than 1. Now this solution here tells us it's no longer just 1 point. You have an interval. All the number, as long as the number is less than 1, that will satisfy of my question. So if I draw a number line, I label a 1, I put an open circle because there's no equal sign here. You can pick the 0.9999999, but you cannot pick the 1 because x must less than 1. So 1 is not a point of x. But you can pick the number super close to 1, okay? But you just cannot pick the 1. And that's why I put an open circle. So as long as the number is less than 1, that will satisfy my question. So I shade the line toward to the left-hand side forever. So if I give the solution set of this question, I will provide a solution by using the interval. Call this is interval. So the interval notation would be from here up to here. Since it's open circle, I go with the parentheses. In the left hand side, because it's a negative infinity, nobody knows what is the endpoint of the infinity, right? So there is no endpoint. And that's why I put the open parenthesis to cover the left hand side as well. So you put a negative infinity, comma, 1, open. So the solution set would be negative infinity, comma, 1 to satisfy when 4x is less than 4. Now we do this question. We have 3 times x plus 2 less than 8, right? So you can distribute here and solve for it. Or you can just simply to divide by 3. Some of you might see divide by 3 on both sides, but it doesn't matter. There's many different approaches to solve it. So I'm going to multiply 3. I get a 3x plus 6 less than 8. And now we bring the 6 to the right hand side. So 8 minus 6, it will turn to the 2. Divide by 3, you will get x is less than 2/3. So now interpretate the solution of this one. As long as the x is less than 2/3. So I'm going to label the 0 here, 1 here, 2 here. 2/3 is about here. So this would be the open circle 2/3. So any number you can take as long as they are less than 2/3, that will satisfy this question. But you cannot pick the 2/3 exactly. Okay, so your interval notation will from here up to here. This is a negative infinity because of the left hand side, and the right hand side you'll have the positive infinity. So the interval that satisfies this question would be negative infinity, comma, 2/3. And it's open parenthesis here because you don't have the equal sign. So we put the open circle. Okay, let me do another example here. What if we have the inequality with negative 3x greater or equal than 4? So solving same way, we isolate the x itself. So we divide by negative 3 into the both sides. When I divide by negative 3, keep in mind, according to the property of the earlier property we went over, when we divide by a negative number in the inequality question, we have to swap the sign because your c is a negative number. So I'm going to change the direction of the inequality into the other way around. Now the right hand side, we will have the negative 4/3. I can bring the negative sign to the side. So when you interpretate the x is less equal than negative 4/3, I'm going to label this is 0, this is a negative 1, this is a negative 2. Negative 4/3 is a little bit bigger than negative 1, right? So it would be here, negative 4/3. and it's a closed dot because you have the equal sign. So I'm going to put a -4 here. Now, as long as the number is less equal than -4, same way, it will go to the left-hand side forever. So the interval notation that indicates the solution set of this question would be from here up to here. Now, since it's a closed dot, we put a bracket to cover this endpoint. So your interval notation, the left-hand side has a -infinity, and the right-hand side endpoint is -4/3. Solving the compound inequality. So the compound inequality, that means you have two inequality signs occur of your equation, inequality equation. So we take a look at the example. We have the 3x minus 7. The 3x is in the middle term. So I'm going to get rid of 7. So the way we get rid of 7, we add a 7, right? So add a 7 on each interval because you have two inequality signs. So when you add a 7 here, you have to process the same number into each interval. And then you have the 12 less than 3x and the less equal than 15. We want to see the single x, not the 3x. So divide by 3. Divide by 3 into each interval. So by the end, you have the x is greater than 4 and the less equal than 5. If I interpreted this solution by looking at the interval notation, I label the 5. 5 is a closed dot because it has an equal sign. 4 is an open circle because there's no equal sign with the 4. Now the x is between 4 and 5. It's bigger than 4, but not exactly 4, right? You can have 4.009, 4.00009, but not a 4. So bigger than 4 and exactly equal 5 or less than 5. So your interval will cover from here. This is open, right? I use a parenthesis, and the right-hand side endpoint is a bracket. So any number between 4 and 5 that will satisfy of this inequality question.